So we're going to go over how to simplify these complex numbers when we have a denominator with a either a complex or an irrational denominator. So the first thing we need to talk about is the word conjugate. So conjugate, kind of like the word conjugate, like if you've ever taken like another language, you conjugate a verb. And so I always think about the word comer, right, in Spanish. So it's como, comes, come, comemos, comen. Okay. If you notice when you conjugate a verb, there's a part that stays the same and there's a part that changes, right? And so the conjugate of a number, and in this case, the complex conjugate, is simply when you take the terms and you keep them the same. So I'm going to keep a here. I'm going to keep. Oops. Let's do this so that it stays in math. So I'm going to keep a here. I'm going to keep bi here. Okay. And then here, instead of this plus, I'm going to change this to a minus. Okay. And that's how you find the conjugate. So again, the way you find the conjugate is you keep the terms and change the operation between them. Okay. And I can make this really, really like difficult looking, but the whole point is you just make the complex part of your number that guy's opposite, right? Notice A stays exactly the same. Okay, so the complex conjugate of I on the bottom, again, just changing the sign of the complex or imaginary part is now negative I. And when you do this, you'll notice, and this is your job. Your job is to get rid of or to rewrite it so that you don't have any complex or irrational numbers in your denominator. So you basically want your denominator to be a whole number, a integer. Even a decimal is okay because you guys all know how to move the decimal over. That's not a big deal. But you don't want it to be an irrational or a complex number. Okay, so I'm going to do this one. Yeah, I'm going to do this one. So the very first thing that it says, okay, I want you to divide 2 plus 3i by 1 minus 2i. So at first it looks like this thing is done, like you can't do anything else with it. You can't factor anything else out of it. But this should look wrong to you. So the denominator having an I in it should look wrong to you. So the way it should look wrong to you is like if you've ever seen a little kid write, they write their A's backwards like this, or they'll write one of their letters backwards. So see how this looks wrong to you? This should look just as wrong. Like, does everybody understand what letter this, little 3 or 4-year-old is trying to write? Everyone's like, yeah, I understand what you're saying. But now we got to bring this to the next level by making sure that we don't leave our answer here. So the problem with this, and I'll just, type it out here maybe so that everyone sees. So the problem that we have here is that we have a complex or irrational number in the denominator. So we can have complex numbers in the numerator. We can have everybody in the numerator. The denominator is very special. So that's why like you can't divide by 0. That's why we have to do what we call rationalize this denominator. So the way we rationalize this denominator is we have to first come up with the conjugate. So in this case, what's our complex conjugate? Someone already put it in the chat. Thank you. So our complex conjugate in this case is going to be 1 plus 2i. So notice our 1 stays the same, but our complex part, the plus 2i, I should say the imaginary part, my bad. The imaginary part actually changes to its opposite. Here it's minus 2i, so here we change it to plus 2i. Okay, so we're going to take this and we're going to multiply it by both the numerator and the denominator. So we're going to multiply this by the numerator and the denominator. Ms. Johnson, why are we multiplying by both the numerator and the denominator? Really, because this is really just the number 1. And so my students make fun of me because I try to draw this as a number one, like a really big one, but then they just end up saying that it looks like a big old t-shirt or half of a t-shirt or a t-shirt without a sleeve. So the reason why I'm drawing this as a one is because I'm trying to remind you that we're not multiplying by just any old number. We're not multiplying by the conjugate. We're actually multiplying by the number one. And you've known this since like second grade. What happens to the number when you multiply it by one? What happens to the value of that number when you multiply it by one? So I'm going to say it again. What happens to any number when you multiply it by the number of one? Yeah, it stays the exact same. So that's the reason why we're multiplying by one, because really we're just going to give this guy a makeover, but his value is still exactly the same. So the equivalent idea would be like, I need change for a 20. So I give you a 20 and you give me two tens. The value is still the same, but the look is different, right? If you've ever done this, it's kind of a cute thing to do. If you go up to a child who doesn't really understand the value of money, show them three $1 bills, show them a $5 bill, one $5 bill, and say, which one do you want? Which one do you think that they would pick? Which one do you think a child would pick? Like, I'm talking a little child that doesn't really understand the value of money. Yeah, they'd pick the three $1 bills. Why would they do that? Because they think the more that I have, and look, I can like make it rain, I could do all these fun things with it. But they don't see that it's really the one $5 bill. And if you've ever had like tried to convince them, they're like, no, you're not going to fool me on this one, right? So then I'm done. So then I'm just going to now multiply these two together, and then I'm done. So when I do this, I actually use the box method. You guys all know that I like this guy. So I'm going to do this to the top and to the bottom. You should notice a pattern in the bottom. I know that I did a good job if my numerator only has real numbers in it and no complex or irrational numbers in it. So I'm going to do this really quick with you. So this is 2 plus 3i, annotating on Zoom here, guys. And then this is going to be 1 plus 2i. So I'm going to go ahead and take care of that while I set up my other one. For those of you who like to write your plus and minus signs, I like to put it next to the second term so I don't lose any minus signs. I don't like losing minus signs. Very good. Okay. So that's done. Okay, so now I'm going to go in and start filling in with you. So 1 times 2 is 2. 1 times 3i is 3i. 2 times 2i is 4i. Okay, now I'm going to do this one slow, right? So 2i times 3i. What is 2i times 3i? Yeah, very good. It is 6i squared. And if you remember, this is my definition guy over here. I squared is equal to what? Who remembers what I squared equals to? Yeah. So if I equals to the definition of I is the square root of -1, I squared is also defined as -1. So I'll say that again. I is defined as the square root of -1. I squared is defined as -1. Okay. So then this equals to -6. And so I'm just going to add like terms here. And so I'm going to go back to my little typer. So my numerator, oops, did I put equals? Not yet. Equals. And then my numerator is going to be, let's see, I put the real part first. So that's -6 plus 2, which is -4. And then 3i's plus 4i's makes 7i's. And yes, I say i's so that everyone can like go back to 3 oranges plus 4 oranges is 7 oranges. Okay, so that's that part. I'm going to go back here. I'm going to start filling this out. Let me use a different color. So then this is 1 plus 1. This is 1 times negative 2i. This is 1 plus positive 2i. I said that wrong. 1 times positive 2i. And negative 2i times positive 2i is negative 4i squared. So in reality, that's negative 4 times negative 1, which is now just positive 4. What happened? What happens to our i's in this case? Does anybody see it? What happened to our i's in this case? Yeah, they all cancel out. And is that important? Is that important for our i's to cancel out? Is that important? Is that something that I wanted to happen? Everyone's like, yeah, Ms. Johnson, we wanted them to cancel out. That was the whole point of you doing this, right? So I'm just going to give you a red flag. If you do this and your denominator still has i's in it, right? If your denominator still has i's in it, you need to go back and check your answers, check your conjugate, check your multiplication, check something, because you did something wrong. So yeah, so 2i minus 2i, that's 0. 1 plus 4, that's 5. So I'm going to write 5 here. So this is my total answer. I'm going to see if I can divide out any other terms. I don't see a 5 in negative 4 and 7i, so I can't simplify. I can't simplify this anymore. Just a little note, just so that we are on the same page as a reminder. So if you had something like 2, oops, that's in yellow, my bad. Let's try green. Let's say you had something like 2 plus 3i, and the denominator was divided by 2. You cannot cancel these 2's. You cannot cancel these 2's because this 2 is under both of them. In order to do that, you'd have to pull a 2 out of both of them. Okay, so you can't cancel these 2's. So don't fall into that trap because that's not correct. For those of you who are like, Ms. Johnson, I'm not really sure if I believe you. Check this out. If I pull a calculator over here, now I can't use this with the i's, but just kind of like realize with me so that you guys can check your math. It's always good for you guys to check like, oh, I wonder if I could do this. So I'm going to ignore the I for just a second, just so I can prove to you. So 2 plus 3 parentheses divided by 2. Is that the same? Now, if you canceled this, you would say 1, right? You would cancel these and it would just be a 1. So you're saying that that's the same as 1 plus 3. Are these two numbers the same? Everyone's like, no, Ms. Johnson. So then therefore you cannot cancel those two, meaning I am saying, let me put this in a blue. These two are not the same because you canceled that 2. I don't know how to do it. Oh, I can just go like this. Hold on. I have an idea. Sorry, I'm trying to show you that you can't just cancel these 2's. Let me change the color here. You can't do that. You cannot do this. This is not equal to. Okay, so just some tips there, just so that you know how to work with a complex conjugate. So one more time, I'm going to say this again. Your goal for this whole thing was to get rid of your i's in the denominator. So did I do that? Everyone's like, yes, Ms. Johnson. Okay, but how did I do that? The way I did it is I multiplied by the conjugate on the denominator and the numerator. And then when I did that, my i's all canceled out. Does anybody see this pattern right here? I know some of you recognize this pattern. Does anybody see this pattern right here in the denominator and the denominator? Your number and its conjugate. Does anybody see that pattern? Recognize it from maybe like your sophomore year, probably. Does anybody see that? I know we've talked about it in here before, maybe very short though. Yeah, it's the difference of squares. Very good. So just as a reminder, this is that a plus, oops, wait, let's do this guy. So a plus b times a minus b equals a squared minus b squared. So this is that pattern of difference of squares, and maybe I'll say that. which means this, right? When you're dealing with difference of squares, notice that our middle terms went away. Like if you used FOIL, your OI, your O and I went away. See, O and I went away. And that's important because you know that, that means your eyes will go away when you multiply a number and its conjugate. Okay. All right. So there's a couple of practice problems that I want you to try. If this is a thing that I've been asking my students lately, what part here, if I gave this to you on a test, what part here is going to trip you up? Is it coming up with the conjugate? No, you guys are good at that. Is it multiplying the top and the bottom? I don't think. I think you've done this since like fraction land, right? Fifth and sixth grade. Is it actually multiplying out here? Probably not, because you've been doing this since at least maybe seventh and eighth grade. I don't know. If you use the area model when you were learning how to multiply, you've been doing this for a really long time. For me, I think the piece that may trip you up is once you get to the I part, right? So here, adding the 4i plus the 3i, are you comfortable with 7i? Are you comfortable with 6i squared being negative 6? So find the part that is like, this is the part that's going to mess me up. And when you walk into that part, just be very cautious and careful.